This is page 60 of your math journal. We're going to give this a title of Equivalent Ratios. Okay, I think you guys can already figure out what this lesson is going to be about. Equivalent means to be equal, and we know that ratio is comparing two quantities together by division. So equivalent ratios are just ratios that are equal. So let's draw a star for this definition. Equivalent ratios. Okay, equivalent ratios are equal to ratios that are equal to each other. And one way we can check that is they will always reduce to the same unit rate. So, ratios that are equal to each other, they will reduce to the same unit rate. All right, let's think about where we might use this. Most times when we're buying things in different quantities, sometimes we get different prices. So sometimes we want to see if we're paying the same price or if they are giving us a different price depending on by ordering more. Example, I don't know about you guys, but it's a possibility to order photo prints online. So we're going to do an example with that. Okay, we're going to say that a company online has two options you can order. Okay, option one. So let's write example here. Example, and then we're going to write ordering photos online. Oh my goodness. Online. I don't know what I thought I was writing there. Online. Okay, so option one. You can order 200 prints for $30. Option two. You can order 500 prints for $75. Okay, if we're trying to figure out if these are equivalent, we want to know if we are paying the same price for every print or if we're getting a better deal with one or the other. So, if we can reduce each ratio to its simplest form or to a unit rate, whichever ones will work for us, but we want to get the numbers, something about them to be the same. So right here, I'm thinking about reducing these. I can see that 10 will go into both of these ones. So if I take option one, and we're just going to reduce it as low as we can. So we have 200 prints for $15. Option two, we had 500 prints for $75. So here, if I'm reducing this down, I can see that, oh, not 15, $30. Make sure you have the right numbers or it will mess you up. $30. Okay, I can see 10 will go into each of these, so I'm just going to reduce them down. So if I divide this by 10, and I divide this by 10, then I can get this to be 20 prints for $3. Okay, that looks like the lowest I can get that to without getting decimal numbers. Is it possible to get decimal numbers? Absolutely. Here, I see that 5 will go into both of those. So if I divide this by 5, and I divide this by 5, this divided by 5 is 15. This divided by 5 is 100. So, or not dollars, prints. So here I can get 100 prints for $15. Okay, notice here these are written in two different numbers, so I can't accurately compare them until at least one of these numbers is the same. But if I can get this to 20, I know that I can divide this by 5, and 15 will divide by 5 nicely, so I'm going to divide this again. So divide this by 5, divide this by 5. That leaves me with $3 on this side and 20 on this side. Well, now that I reduced it here, I can see that it doesn't matter which one I order, I can still get it. Both of them give me 20 prints for $3. This one, if I only need 200 pictures, maybe this is the better one to go. If I need 500, I could order this one, but it doesn't matter which one I pick. I'm still spending the same amount for the same number of prints. I could go down to the unit rate. I could figure out how much it cost me for just one print. But as long as I can get both of these ratios to show me the exact same, I'm proving that these are equivalent to each other. Okay, let's try another one. Let's say you're comparing two sports players. Okay, so we are going to do another example. Okay, comparing sports statistics. Alright, let's say you and a friend are in a competition with each other. Okay, you make 3 free throws. Out of 7 attempts. Okay, your friend made 9 free throws. Out of 14 attempts. We're trying to figure out which one of you has a better ratio of free throws made compared to the attempts. So if we look at you, we have 3 free throws. I'm just going to write F for 3 throws. Let's write it out. Free throws. Out of 7, right? Your friend has 9 free throws. Out of 14. Well, looking at these right now, 3 and 7 is as reduced as it can get. 9 and 14 is as reduced as it can get. But so we can feel like we can accurately compare them, we want to change one number so it's the exact same as the other one. So here, what can I do? I can either turn 3 to 9 or 7 to 14. Doesn't matter which one I want to do. But I'm just going to try and, if you were to make 9 free throws based on what you've done here, how many attempts would it have taken you? So if I want to turn it into 9, I could times this by 3. But I'd have to times this one by 3 as well. So that for you to make 9 free throws following your same patterns, it would have taken you 7 times 3 would be 21 attempts. So it would take you 21 attempts to get 9 free throws, and your friend only took 14 attempts to get 9 free throws. So of these two, your friend right now is the better basketball player. So looks like you need to do a little practicing. Okay, so sometimes we just need to get something to match up to either prove that they're equivalent or not. In this case, 9 over 21 is not equal to 9 over 14. But since we got both of these to be 9, we're proving that they are not equivalent. Up here, we got both of these to be 20 for $3. So they were equivalent to each other. And that's all I need you to write for this lesson.